All right, can start class again and question and schedule. No questions. All right, so we can move on to finish up the chapter 2, including Agada. All right, so redefining the space of designs. So we can say the space of design is a set of design alternatives. There are so many set alternative designs. So for the smartphone design for Indian ladies, everybody can raise his own designs, right? Each one can produce several designs, right? So including all of them can be a space. And then how can we define the space itself? The space usually drawn as a circle, right? And then redefining means we can modify the size of the space. So we can change the boundary of the space. That is the meaning of the redefining. And contents. We are working on this book, textbook, and chapter 2 we will finish up today, knowledge-based model. And then I'm talking about 2.5. I missed that. 2.5 should be. 2.5 is redefining the space of designs. Right? No. Formal models. Something mixed up, right? So we'll talk about formal models of design system. Right, starting, okay. And formal model of design system is trying to make trying to formulate the design system into an equation. Looks like an equation. Right? And axiomatic design. This is a terminology created by Professor Soonhung, who was president of KAIST several years ago. He was a professor in MIT. His intention is trying to make design into something like a theoretical background. Historically, design looks like art rather than science. Many people still think about design as art rather than a science. Say in KAIST we have another department called industrial design. Is it right? Industrial design. Right. They are more oriented for artistic design, commercial, say shape design or look, say, how can I say? For the car design, they are focused on outside shape rather than inside engine or thickness or strength, right? In engineering department, we are talking about design of engineering design. That is more oriented to the strength and performance, right? And we are talking about sizing, thickness, and speed and power. It looks like that. But industrial design, they are more oriented to the artistic viewing, seeing, right? So in that sense, that is more oriented to artistic way rather than science. Engineering design is a little bit more including science or theories, right? Calculations, computation. Right? And Professor Soonhung, he is trying to make more design, the whole design system as more theoretical background, make a theoretical background. So here, again, we are trying to make design system as theoretical equations or mathematical equations. Looks like a mathematical equation. So, formal model of design system. So it is, we already talked about the design is similar to language system. There's an analogy between design and language. And also we learned about three types of reasoning process: deduction and abduction and induction. And deduction is similar to design interpretation or performance estimation or performance prediction something. And abduction is similar to generating design itself. So that I said sometimes they are in reverse way. Chicken and egg game, something like that. And induction is different a little bit, that they are talking about generating knowledge itself, creating knowledge itself. So knowledge base is created through the induction process, or theory itself is created. Also, it is related with the learning system, education. And I will cover about 2.1 mainly, and then some part of product and design process. So analogy between design and language, this is already covered the other day. Right. So language and design, and there is in language there is a word, grammar, and sentence, and meaning of the sentence. Right? That is correspondence is to the engineering design is a part. So a smartphone is made of many parts, probably 100 parts or less than 100, depending on how do you divide them. You can divide more than 100 from here. But usually in a company, as a Samsung, they are talking about the number of parts is their identification. Identification is separation depending on how they make them. So mainly it is depending on their purchasing unit. In old days, manufacturers make their parts themselves, so that they're buying. Sometimes they buy raw materials, including raw materials, so that at that time the separation is more numbers. Nowadays, outsourcing is growing up, so that Samsung is doing only assembly, and also buying some crunch of sub-assemblies. Right? More. The trend is purchasing bigger units than before. So the number of purchasing items is smaller than several years ago. So inside one company, the number of counting parts separate identification is reducing nowadays. But the purchasing is outsourcing to another company, right? And that company also, in that sense, is an assembly company. They also purchase parts from sublayers. So we call this is supply chain hierarchies, right? Supply chain hierarchies. And we call this is a tiers. Tier 1, tier 2, tier 3. Means each company is purchasing from different smaller companies. And the layers is going up. Right? We call this is supply chain, or sometimes management, supply chains. Right? This is similar to food chain, animal world, food chain. Right. So back to engineering design, the parts, the meaning of parts is also, I'm trying to explain about these differences. And then grammar, there is a grammar syntax in language also. Or vocabulary can be similar to words, and syntax and grammar. In design, there is some kind of regulations for. It can be changed to regulations, right? And depending on the regulations, we can do some actions to assembly. So for the Lego blocks, there is a rule, right? Rule between parts. How do you mate each other? Right? And then using this words and grammar, we produce sentence. So this is a kind of a design itself, the drawing or product itself. It can be a product. Yeah, this one. Or the CAD model of them, or drawing of this. Yeah. Design drawings. And then in that drawing or in that sentence of Russian language, there is a meaning which should be find out. Right? Because I don't know about Russian language. Once I have given to me a sentence, I could not understand the meaning of this. Very similar to design, right? Design of some new product, and then you should know about the performance of this. Okay, so this is a sentence, right? The boy eats the apple, right? So we can divide them into parts. Each word is, and then this word is corresponding to a follow of the language grammatical rules, regulations. And then also we can divide them into the types of the word or their position in there and their duties there. And then this is also corresponding of assembly of a product. Right? And this picture is coming from chapter 3, so we will see once again in chapter 3. But anyway, that product or sentence in language can be divided into several parts. And that parts assembled together to produce final product. Right? So there is a correspondence between design and language. Okay. Right. So formal model of design. Right. So in design we can do some mathematical notations. So design itself can be used as notated as D. Design description. Description means simply it's a drawing or CAD model. You can think about that. Right? Design itself. And vocabulary is a part of that design. So previously here, you see, this is the description, so it's a D, right? And that can be a part. So parts and D. So vocabulary, they are saying V and D here. Next slide. And then knowledge. Knowledge is regulations or grammatical rules, right? In construction. There are more knowledges, but simply for the assembly is the assembly knowledge. And this is more specifically the assembly knowledge, right? Syntactic, grammatical, or generative knowledge. And there is another type is interpretive knowledge that is used for interpreting, finding out the meaning inside the sentence. And then interpretation, using interpretive knowledge. And there is two different subtypes of interpretation. One is intended interpretation or required interpretation. That is similar to objective of the design. I want to design a smartphone for Indian ladies. Right? That is intended requirement, design requirement, objective. And then once you design a smartphone for that Indian lady, each one has their own design result, right? Description. And then we should test whether this one is good for really good for intended interpretation. That is, we can say, actual interpretation. So using interpretive knowledge, we can test, evaluate each design result coming from each designers, and find out which one is better. Right? Which one is better? We can select among them. So that's why we can use interpretive knowledge for the abduction process, generating process. So this one is already shown several times, but here they separate out this knowledge from this knowledge. And this knowledge is KI, looks like interpretive knowledge. This is KS, generative knowledge, or syntactic or grammatical knowledge. And that is used starting from intended interpretation, right, to arriving at description or design. And we call this is abduction process. And this one is, they don't use any intended interpretation. They just use the regulations of mating conditions, assembly conditions, grammatical rules, right? So they can produce many syntactically correct descriptions. And so that there are two different space of designs are generated. And using this, we said something like this one, right? Me ice cream is coming from abduction process, the right part of this previous slide, right? Right part. Using intended interpretive knowledge. Using syntactic knowledge, we arrive at colorless green ideas sleep. So this is a grammatically correct one, but does not have any meanings because we did not start with intended interpretation. So deduction is interpretation, right, or analysis. Here we start with a given design, using interpretive knowledge, arrive at interpretation, the performance of that design. The weight, the cost, or strength, right, performance of this design. So we call this a deduction. And in abduction, we start from intended interpretation. And then using interpretive knowledge, we arrive at our own design. So I want to design a smartphone for Indian ladies. Okay? And using your knowledge, everybody has, because you are engineering student, right? Graduate student, So you can already have many good knowledge. So using your knowledge, generate your own design for Indian ladies. So you produce many this kind of design. But in syntactic knowledge, using vocabulary parts, Lego parts, and using the regulation rules for assembling Lego blocks, you can produce many syntactically correct generations. So the generate and test model, we just generate many this kind of designs. Question? Right? So a little bit more complicated equation now, right? So generate and test. Generate and test is you just generate without thinking about the performance. Right? Just generate using only regulations, rules, grammatical rules, right? And then test whether this is good. Simple way, because it's simple for computers. Simple enough for computer. Because computer is very fast. Right? And simple work is good for computer. So they do many simple works. And then at the end, they can beat humans, right? By using that kind of policy. Simple work, many simple work. 1,000 times faster than human. And then final result looks like better than human. Right? That is a policy. Anyway, so it is generate using syntactic knowledge, using vocabulary, and then no, this one is not anyway. And then using interpretive knowledge, they should find out whether this is satisfy the intended interpretation, and finally arrive at a design. Right? So that policy can be used by, actually human also do something like this one, sometimes. Right? Knowledge acquisition, a little bit more higher level knowledge acquisition. How can we arrive at this interpretive knowledge or syntactic knowledge? Both are categorized as induction, but a little bit different. And also, they use many different designs, right? Hundreds of designs. But using here is a vocabulary or grammatical, correct vocabularies, right? This one is interpretation of performances. So they trying to find out the new rules, new knowledges. Say, I said several times that simplest form of knowledge is if rule, right? If alpha and then beta is true, right? If alpha is true, then beta is true, right? This is the simplest form of knowledge. So we can create such knowledge pieces using this many. But this one is not simple operator, but anyway, observations, finding out patterns. Right? Something like a Kepler, or something like a baby who is learning about language, right? New language. So we creating our knowledges about this. Okay, and this is parsing, something like a parsing. Right? So for given sentence, using syntactic knowledge, we divide them into simple parts or simple wording, right? Vocabularies out of it. So parsing is similar to this process. Okay, that is almost done. Right.